Okay, question 14, final question, bit of SUVAT, 17 marks overall, I think. Show the velocity v meters per second of a car is being modelled. Initially, the car has a velocity of 5 meters per second and it accelerates to 11.4 meters per second in 4 seconds. Part 1 wants us to, in Model A, the acceleration of the car is assumed to be a uniform, so constant acceleration. Part 1 wants us to find an expression for the velocity of the car at time t using this model. Okay, so what do we know? Well, we know that u is 5, we know v is 11.4, and we know that t is 4. Now, using those three things, we can work out the acceleration. So, we know that v is u add at. So we're going to use this equation twice. Once now to find acceleration, and then again for our equation for the velocity. So, if v is u add at, we know a is v minus u over t. So, plonking in our numbers, we get a is 6.4 over 4. 6.4 over 4 is 1.6. So our acceleration is 1.6 meters per second squared. Now that we know that, we can say then that v is u, so 5 add 1.6 t. Cool. Part 2 wants us to explain why this model is inappropriate in the long run for 1 mark. Okay, so the model implies infinite acceleration, which means as t tends to infinity, v tends to infinity, which makes no sense. So is inappropriate for large t. Okay, next up, we are told that Model A is refined so that the velocity remains constant once the car reaches 17.8 meters per second. Part 3 wants us to sketch a velocity time graph for the motion of the car, making it clear where the acceleration changes. Okay. So, Okay, so we know that u is equal to 5 meters per second. So if we got velocity here in meters per second, and along the bottom we got time in seconds, then we know initially the car has a speed or a velocity of 5. Now it's going to accelerate constantly, so we use a straight line till it gets up to 17.8, and then from that it's just a horizontal line. So we know that this needs to be 17.8 meters per second. So what we can do is use our formula for V. V is U add AT to work out T. So we know that 17.8 is equal to 5 add 1.6 T. Take away the 5, 12.8 is 1.6 T. Divide by 1.6, T is 12.8 over 1.6, which gives us 2 seconds. Eight seconds. So the time at which the acceleration changes is 8 seconds. Cool. Part 4 for another 3 marks wants us to calculate the displacement of the car in the first 20 seconds according to this model. Okay, so distance travelled is area under the graph. So we need to work out 2 areas, let's do it over it. Okay, so we know that at 8 seconds the velocity becomes constant, so 20 seconds is 12 more to the right, so the displacement in this rectangle is gonna be 12 times 17.8 and then for the first 8 seconds we have a trapezium. So for a trapezium we need to know the height, which here is 8, the top side just 5, and the bottom side, which is 17.8. So the area of that bit, remember for a trapezium it's height times a plus b all over 2. So that's going to be add 8 times 5 add 17.2, which is, sorry, 17.8, which is 22.8 all over 2. So work that on your calculator, let's see what we get. Okay, we should get 304.8. Cool, and of course, that's meters. Okay, then in model B, the velocity of the car is given by V is 5 add 0.6 t squared minus 0.05 t cubed for t greater than or equal to 0, less than or equal to 8, and 17.8 for t greater than 8 but less than or equal to 20. Part 5 wants us to show that this model gives an appropriate value for V when t is 4. So, and let's do that over here. So, t is 4 gives us that V is 5 add 0.6 t squared, which is 4 squared, so 0.6 times 16 minus 0.05 times 4 cubed. So 64. See what we get. Okay, that's going to give us 11.4. And that is meters per second, which matches what we were told at the start of the question, so it's an appropriate value. Good times. Okay, then for part 6, we want to explain why the value of the acceleration immediately before the velocity becomes constant is likely to mean that model B is a better model than model A. Okay, so in model A, what was happening is we're going from constant acceleration and then we snap to 0 acceleration, and that is incredibly unlikely to happen. You're going to accelerate fastest at the start, and then your acceleration is going to start decreasing and decreasing until you reach your maximum velocity. So what we are going to do with model B is find the expression for the acceleration and check what it is at t equals 8. So if the velocity is 5 add 0.6 t squared minus 0.05 t cubed, then we know acceleration is the derivative of velocity with respect to t. So this is going to give us 1.2 t minus 0.15 t squared. So that is our expression for the acceleration. Now, when t is equal to 8, the accelerate, why do I say 8 and write a 0? So when t is equal to 8, there we go, good. When t is equal to 8, acceleration is 1.2 times 8 minus 0.15 times 64. Now that is going to give us 0. Now this means then that velocity reaches its maximum at t equals 8. So that means then immediately before t is equal to 8, the acceleration is slightly bigger. Slightly bigger than 0, but decreasing as t tends to 8. Now, this makes it a better model. As model A snaps from constant acceleration to 0 acceleration. Cool. Okay then, part 7 for 3 marks wants us to show that model B gives us the same values as model A for the displacement in the first 20 seconds. Okay, so we know that velocity is the derivative of displacement, so S, displacement, is the integral of velocity. So, with respect to t, so in the first 8 seconds, displacement is the integral between 0 and 8 of 5 add 0.6 t squared minus 0.05 t cubed with respect to t. So that's going to give us 5t plus 0.2 t cubed minus 0.05 over 4 t cubed between 8 and 0. Now we know that when t is equal to 0, we're going to get 0. So all we need to do is sub in t equals 8, which is going to give us 91.2 meters, and then we know for the last 12 seconds it's the same as it was before because our velocity is constant again. So for the last 12 seconds again it's 17.8 times 12, which is 213.6. So altogether 91.2 add 213.6 gives us again 304.8, which was the same, which is the same as model A. Boom. And with that guys, paper done. If you guys want paper 2 and paper 3 done, please let me know down below in the comments, give us a thumbs up, get subscribed. Takes a lot of work, so I'm only going to do it if there is demand. Good luck in your exam guys, take it easy, take care.